January 23, 1943, Eastern Front, 30 kilometers west of Rostov-on-Don. Obersturmführer Karl Weiss stood in the commander's cupola of his Tiger tank, scanning the vast white expanse of the Russian steppe through binoculars. The temperature had plummeted to minus 27 degrees Celsius overnight, but inside the 57-ton steel behemoth, the crew worked in their shirt sleeves, warmed by the heat of the Maybach HL-230 engine. Weiss permitted himself a thin smile. The Tiger was the pride of the Wehrmacht, a mechanical manifestation of German engineering superiority. Gunner, target at 2 o'clock, T-34, approximately 1 to 200 meters, Weiss ordered calmly. The massive turret rotated with surprising smoothness, the electric drive humming as it brought the 88mm KWK-36 gun to bear on the distant Soviet tank. Through his gun sight, Unteroffizier Manfred Keller could see the Russian vehicle, its silhouette barely visible against the snow-covered landscape. "Target acquired," Keller announced. "Fire." The Tiger shuddered as the 88mm round left the barrel at 810 meters per second, a perfect shot that struck the T-34 squarely in its front glacis plate. Even at this distance, they could see the explosion as the Soviet tank erupted into flames. "Target destroyed," reported Keller mechanically. It was their fourth kill of the morning. The Tiger's gun could penetrate 112 meters of armor at 1,400 meters. No Soviet tank could match this lethal reach. What Weiss didn't know as he recorded the kill in his logbook was that for every Tiger on the Eastern Front, Soviet factories in the Urals were producing 63 T-34s. For every precisely machined part in his Maybach engine, American factories were stamping out thousands of standardized Sherman components. For every Tiger's hand-finished weld, British assembly lines were churning out 25 Cromwell tanks. Back at the Henschel factory in Kassel, senior engineer Erwin Ades frowned at the latest field reports. Bearings failing, transmissions breaking, final drives seizing. The Tiger was experiencing a 55% mechanical failure rate before even reaching combat zones. Ades turned to his colleague, Ferdinand Porsche. "It's the weight," he admitted quietly. "The transmission and final drive were designed for a 35-ton tank, but we've delivered a 57-ton monster." The Tiger had begun as a modest proposal, a 40-ton tank with adequate armor, but Hitler had demanded more: thicker frontal armor, bigger gun, wider tracks. Every addition required compensating adjustments elsewhere in the design. The overlapping wheel system, meant to distribute weight more effectively, was now trapping mud and freezing solid in Russian winters. The sophisticated 8-speed transmission, a masterpiece of engineering, was breaking under stresses it was never designed to handle. From his production office in Detroit, American engineer William Knudsen studied photographs of the captured Tiger. "Impressive but impractical," he concluded. "They're building a Rolls-Royce when what they need is a Ford." Under his direction, American factories were producing M4 Shermans at a rate of 45 per day, simple, reliable, and good enough. In the 11 months it took Germany to produce 1,347 Tigers, American plants delivered 49,234 tanks. On the same day Weiss was claiming his fourth kill, Captain Robert Sorley of the U.S. Army Ordnance Department was overseeing the unloading of 276 brand-new Sherman tanks at the port of Liverpool. "Not the best tank in this war," he told his British liaison, "but certainly the most available." As darkness fell on the Russian steppe, Weiss ordered his driver to position the Tiger behind a small rise for the night. The temperature continued to drop. Inside the steel hull, the gunner Keller wrote in his diary, "The Russians keep coming. We destroy them by the dozens, but there are always more. Where do they find so many tanks? So many men? Sometimes I wonder if we are fighting a nation or a force of nature." What Keller could not know was that in Chelyabinsk, known as Tankergrad, 60,000 workers labored in shifts around the clock, producing T-34s at a rate that German intelligence officers in Berlin found simply impossible to believe. The next morning, as dawn broke over the frozen landscape, Weiss's Tiger refused to start. The transmission, subjected to stresses far beyond its design parameters, had finally failed. As the crew struggled with frozen tools, the distant rumble of Soviet artillery grew steadily closer. Chapter 2. The Fatal Flaw. February 15, 1943. Henschel and Son Factory, Kassel, Germany. Dr. Ernst Kniepkamp, head of the automotive design department at the German Army Weapons Agency, stood silently as workers disassembled a Tiger transmission returned from the Eastern Front. The 8-speed Maybach Olvar EG 40 1216B transmission, a marvel of engineering precision, lay in pieces on the workshop table, its gears revealing patterns of stress fracture and metal fatigue that told a story of catastrophic failure. "This is the third one this week," said the foreman, pointing to the damaged gear teeth. "Same pattern every time. The driver shifts from fourth to fifth under load and—" He mimicked an explosion with his hands. Kniepkamp nodded grimly. The Tiger's transmission had been designed for a 35-ton tank. Now, at 57 tons, the stress on every component was nearly doubled. Each Tiger required 300,000 man-hours to produce, 6 times more than a Soviet T-34. Every transmission contained precision-engineered parts that required skilled machinists, special alloys, and exacting tolerances, and they were failing at an alarming rate. "We need to redesign the entire powertrain," Kniepkamp said. "With what resources?" replied Ferdinand Porsche, who had just entered the workshop. "The Führer wants production increased, not halted for redesign." Across the English Channel, in a nondescript building in Chertsey, British intelligence officers were examining transmission components salvaged from a Tiger captured in Tunisia. Captain Michael Dewar of the Royal Electrical and Mechanical Engineers shook his head in amazement. "Look at this," he said to his colleague. "They've machined this gear to a tolerance of 0.02 of an inch. It's beautiful work, but completely impractical for mass production." In contrast, the Sherman's transmission was robust, simple, and manufactured to tolerances that allowed for rapid assembly by semi-skilled workers. It wasn't elegant, but it worked. For every hour German engineers spent perfecting the Tiger's transmission, American factories produced 3 complete Sherman tanks. At the General Motors Transmission Division in Detroit, engineers had embraced a different philosophy. "A tank that can't move is just an expensive bunker," Chief Engineer Walter Bradley told his team. "I want a transmission that any farm boy can fix with a wrench and a hammer." The resulting hydromatic transmission could be mass-produced, easily serviced in the field, and while it lacked the theoretical efficiency of the German design, it delivered something more valuable: reliability. Back on the Eastern Front, Maintenance Battalion 559 was struggling with a crisis. Of the 12 Tigers assigned to Panzer Regiment 503, 9 were immobilized with transmission or final drive failures. Technical Sergeant Werner Becker surveyed the disabled tanks with growing despair. Each repair required parts that were increasingly scarce, specialized tools that were often unavailable, and technical skills beyond most field mechanics. "The tolerances are too tight," Becker complained to his commander. "Mud gets in, bearings seize, and then the whole drivetrain goes. The crews are afraid to use reverse gear because it strips the teeth every time." In his Berlin office, Albert Speer, Reich Minister of Armaments and War Production, reviewed the production figures with growing alarm. For every Tiger that rolled off the assembly line, the Soviets were producing 24 T-34s. American factories were delivering a Sherman tank every 30 minutes. The British had simplified their Cromwell tank to the point where unskilled workers could assemble major components. Germany, meanwhile, was still relying on master craftsmen whose numbers dwindled with every bombing raid. On the drafting tables at Henschel, engineers were already designing the Tiger's successor, the even heavier King Tiger. Its transmission would be marginally improved, but still fundamentally inadequate for a tank now approaching 70 tons. The same fatal flaw would be carried forward, a persistent echo of the original engineering miscalculation. In his diary that night, Dr. Kniepkamp wrote, "We build the world's most powerful tank, yet we cannot keep it moving. The problem is not technical, but philosophical. We design as if resources are unlimited and time is abundant. Our enemies design as if both are running out. Perhaps they understand the nature of war better than we do." At that same moment, in the frozen wastes of Russia, another Tiger sat immobilized, its transmission destroyed not by enemy fire, but by its own weight. Its crew worked frantically in the gathering darkness, aware that when dawn came, they would be defenseless against the waves of Soviet armor that intelligence reported were massing just 7 kilometers to the east. Simple physics and engineering miscalculations were accomplishing what enemy shells often could not. Chapter 3. The Industrial Abyss. March 19, 1943, Willow Run Bomber Plant, Michigan. The massive factory complex stretched over a mile long, its roof covering 67 acres of manufacturing space. Inside, 42,000 workers, many of them women who 6 months earlier had never seen the inside of a factory, were producing one complete B-24 Liberator bomber every 63 minutes. Lieutenant Colonel Helmut Meyer, a German industrial observer captured in North Africa and brought to America as part of a psychological operation, stood in stunned silence as he watched the production line. His escort, Major William Donovan, allowed him a long moment to absorb the scale of what he was seeing. "This is just one factory," Donovan said finally. "We have dozens more." Meyer, who had supervised production at the Krupp works in Essen, struggled to comprehend the industrial gulf that had opened between Germany and its enemies. The Willow Run plant alone was producing more aircraft tonnage each month than all of Germany's factories combined, and it was doing so with a workforce largely composed of former housewives and farmhands. Back in Germany, at the Henschel factory in Kassel, master machinist Kurt Brahm was personally inspecting each Tiger transmission before installation. 43 years of experience guided his calloused hands as they checked tolerances and alignment. Each transmission required 800 man-hours to produce, contained 385 precisely machined parts, and still failed at a rate that was crippling the panzer forces. "We need more skilled workers," Brahm told the production manager. "There are no more," came the reply. "The last apprentice class was drafted last month. We're training women now." Brahm glanced at the small group of female workers newly assigned to the transmission line. Most had never held a micrometer before. The Tiger's complex drivetrain required machining tolerances of 5/1000ths of a millimeter in some components, a level of precision that took years to master. Meanwhile, at the Detroit Tank Arsenal, 20-year-old Betty Morrison, 6 months removed from high school, operated an automated milling machine that produced Sherman transmission casings to within 3/100ths of an inch, more than adequate for the robust simplified design. She was one of 85,000 workers at the massive complex. Together, they produced more tanks each month than Germany manufactured in a year. At Germany's Army Weapons Testing Ground in Kummersdorf, Oberst Heinrich Becker was reviewing the latest Tiger reliability reports with growing concern. After 6 months of combat deployment, the data was undeniable. For every Tiger destroyed by enemy action, 3 were abandoned by their crews due to mechanical failure, primarily transmission and final drive issues. "The problem is fundamental," Becker wrote in his report to High Command. "We designed a drive system for a medium tank and installed it in a heavy tank. No amount of fine-tuning can overcome this basic miscalculation." His report would be filed away, marked "noted" but never acted upon. German industry, increasingly constrained by strategic bombing and resource shortages, lacked both the capacity and the time to redesign the Tiger's powertrain completely. In the Soviet Union, at the Ural heavy machinery plant, production engineer Mikhail Koshkin had embraced a radically different approach. The T-34's transmission contained just 120 parts, with tolerances loose enough that components could be manufactured by unskilled workers using basic machine tools. Soviet tanks frequently leaked oil and required more frequent maintenance, but they could be produced in vast numbers and, critically, could be repaired in the field with minimal specialized equipment. "A perfect tank that cannot be built in sufficient numbers is worthless," Koshkin told his design team. "A good tank that can be built by the thousands will win this war." In April 1943, as the Wehrmacht prepared for Operation Citadel, the massive offensive that would become known as the Battle of Kursk, maintenance reports showed that nearly 45% of Germany's Tiger tanks were inoperative due to transmission and final drive failures. Field workshops struggled to keep pace with the constant breakdowns. Replacement parts were scarce, often taking weeks to reach the front lines. At his headquarters, Field Marshal Erich von Manstein reviewed the readiness reports with growing frustration. The Tiger was a formidable weapon when it worked, but increasingly, it simply didn't work. For every hour it spent in combat, it required 10 hours of maintenance. Its complex transmission, theoretically capable of providing optimal power in any terrain, was proving catastrophically unreliable under actual combat conditions. "We have built a tank that terrifies our enemies when they see it," von Manstein remarked to his staff, "but terrifies our logistics officers even more." In Washington, D.C., at the Pentagon, General Leslie Groves studied production reports from America's tank plants with satisfaction. In the time it had taken Germany to produce fewer than 1,400 Tigers, American factories had delivered over 40,000 Sherman tanks, enough to equip not only US forces, but also their British and Soviet allies. The beauty of American production, Groves told Secretary of War Stimson, isn't that we build better tanks. It's that we build so many good enough tanks that the enemy drowns in them. As the massive armies prepared to clash at Kursk, the fundamental engineering miscalculation in the Tiger's design would prove as deadly to German ambitions as any enemy weapon. For in the final calculation of war, a simple tank that moves is infinitely more valuable than a sophisticated one that doesn't. Gestab Chapter 4. The Reckoning, July 5, 1943. Kursk, Soviet Union. The largest tank battle in history was about to begin. Along a 70-kilometer front, the Wehrmacht had assembled 2,700 tanks and assault guns, including 133 Tigers, the mechanical apex of German engineering. Opposing them, the Red Army had positioned over 3,600 tanks, with thousands more in reserve. In the pre-dawn darkness, Hauptmann Otto Carius completed his inspection of the 8 Tigers under his command in the 502nd Heavy Tank Battalion. On paper, they were the most formidable fighting vehicles on the battlefield. In reality, 2 were already suffering transmission problems, their final drives showing the telltale signs of imminent failure. Keep them in second gear whenever possible, Carius instructed his drivers. Avoid high-speed maneuvers and reverse. If you feel any grinding in the transmission, stop immediately. These were not the instructions of a commander confident in his equipment's reliability. They were the desperate compromises of a man who understood all too well the fatal flaw at the heart of his fearsome weapon. 20 kilometers away, Major Pyotr Cheryomukin addressed the crews of his T-34 regiment. "Their Tigers can kill you from 2 kilometers, he told them bluntly. But they must first get within 2 kilometers, and their tanks often break before they reach you. Attack them from the flanks, force them to maneuver, and many will defeat themselves." It was a strategy born of harsh experience. In the 5 months since the Tiger's debut on the Eastern Front, Soviet commanders had learned that for all its firepower and armor, the German behemoth had an Achilles heel, its overstressed transmission and final drive. Force a Tiger to maneuver aggressively, particularly on soft ground or inclines, and there was a significant chance it would break down. As the battle was joined, the inherent contradiction in the Tiger's design became lethally apparent. Its 88mm gun could destroy any Soviet tank at ranges exceeding 2,000 meters, but to exploit this advantage, it needed to maneuver to advantageous firing positions. Yet every aggressive movement risked catastrophic mechanical failure. By midday, Carius had lost 3 Tigers, not to enemy fire but to transmission failures. As his driver attempted to climb a modest incline, the final drive of his own tank emitted an ominous grinding noise. Metal fragments had sheared from the overtaxed gears, creating a cascade of damage that left the 57-ton vehicle immobilized in open ground. "Abandon tank," Carius ordered, the words bitter in his mouth. The crew extracted the firing pin from the 88mm gun to prevent its use by the enemy, and retreated on foot, leaving the intact but useless Tiger behind. It would be the 517th Tiger lost to mechanical failure since the model's introduction, compared to 387, destroyed by enemy action. In his command bunker at Wolfschanze, Hitler was receiving the first reports from Kursk. The Tiger's fearsome reputation had led him to expect a swift breakthrough. Instead, the offensive was already losing momentum, hampered as much by mechanical failures as by Soviet resistance. "How can the world's most advanced tank be so unreliable?" he demanded of Albert Speer. The Reich Minister of Armaments had no comforting answer. The fundamental problem, an inadequate transmission forced to handle excessive weight, could not be solved without completely redesigning the tank, a process that would halt production for months. And with Allied bombing now systematically targeting Germany's industrial centers, such a delay was unthinkable. At the Ford Motor Company's tank arsenal in Grand Rapids, Michigan, production engineer Samuel Johnson was conducting a durability test on the Sherman's hydromatic transmission. The component was deliberately simple, forgoing theoretical efficiency for practical reliability. Under testing conditions far more rigorous than actual combat, It had run for 500 hours without failure. "It's not elegant," Johnson told the visiting War Department officials, "but it works, and we can make one every 17 minutes. This philosophy, sacrificing theoretical perfection for practical sufficiency, was alien to the German engineering tradition. Yet it was proving devastatingly effective. By the end of 1943, for every Tiger on the battlefield, there would be 65 Shermans, 57 T-34s, and 17 British Cromwells, all with transmissions that, while less sophisticated, were far more reliable. As the Battle of Kursk reached its bloody climax, the strategic impact of this engineering disconnect became undeniable. The Tiger, when functioning, was indeed the most lethal tank on the battlefield, but increasingly, it wasn't functioning. Maintenance reports showed that by July 17th, over 70% of the Tigers committed to Kursk were inoperative, only a fraction from enemy action. In a field repair shop 10 kilometers behind the front line, Master Sergeant Karl Bromman surveyed the row of disabled Tigers with professional despair. Each transmission replacement required specialized equipment, precision parts, and expertise increasingly in short supply. Even when repairs were completed, the fundamental design flaw remained. The replacement transmissions would fail just as their predecessors had. "We are asking them to do the impossible," Bromman told his assistant. "These components were never meant to carry such weight." The Battle of Kursk marked the end of German strategic offensive capability on the Eastern Front. It also represented the moment when the fatal miscalculation in the Tiger's design could no longer be ignored. What had begun as an engineering compromise, using an inadequate transmission, because a properly scaled one would take too long to develop, had become a strategic liability that was helping to lose the war. In the months that followed, German engineers would attempt incremental improvements to the Tiger's drivetrain, but without addressing the fundamental imbalance between weight and transmission capacity, these were merely palliative measures. The Tiger II, entering service in 1944, would inherit and even exacerbate the same fatal flaw, now carrying nearly 70 tons on a powertrain still fundamentally inadequate for the task. By war's end, the statistical verdict was damning. Only 1,347 Tigers were built, compared to 49,234 Shermans and 84,000 T-34s. Of those Tigers, fewer than 30% were lost to direct enemy action. The remainder succumbed to mechanical failure, fuel starvation, or strategic abandonment. In the final analysis, the Tiger's transmission problem represented more than a mere technical failure. It embodied a broader strategic miscalculation, the belief that qualitative superiority could overcome quantitative disadvantage. Germany built tanks that were individually superior, but collectively insufficient, masterpieces of engineering compromised by their own complexity and impossible to produce in decisive numbers. The Tiger's transmission, precision-engineered, theoretically superior and practically inadequate, became an unintended metaphor for the Third Reich itself, impressive in conception, formidable in appearance, but fundamentally unsustainable under the pressures of total war. In the end, Germany was defeated not just by Allied armies, but by the inexorable mathematics of industrial capacity. No amount of engineering brilliance could compensate for a production ratio of 1.65. The fatal flaw in the Tiger's transmission was merely the mechanical expression of a much larger strategic miscalculation, one measured not in broken gears, but in the collapse of an empire. If you found this analysis of engineering failure fascinating, hit subscribe and the notification bell now. Join us next week as we explore how a single design flaw in the Japanese Zero fighter sealed the fate of the Pacific War.